Shifting back to soils, I appreciate the opportunity, Di. I'll be brief. I've presented this information over the past lot of months to several geotechnical firms and structural firms in Christchurch. I'm out of the States, obviously. I've been with Keller in the States, a ground improvement firm throughout the world. A bit of piling, but primarily mitigation of soft ground, liquefiable ground with various methods. I've been in Seattle for 25 years, excuse me. Did live through a 6.8 10 years ago, nothing like yours. A bit farther away, maybe a few $1 billion of damage, no deaths, but a fair bit of liquefaction. So I've played with soft and liquefiable ground, as I've said, between Alaska and California for a number of years. I came here in May. I didn't come down here to tell you about liquefaction or about your experience. Your experience is unprecedented. It's been very harsh, and it's very personal. What I did come down here to do is to offer a bit of the industry, maybe some things that are available in the rest of the world with respect to ground improvement and how they might affect or play into your foundation systems. I typically start by finding my glasses so I can see which button to hit. I will say I quite liked Ian's comments about humility. If you want to work on your humility, you should probably go into ground engineering and contracting. Maybe play a little golf along the way, that always helps. In looking at the underground, I'll just move through some systems here, names you may have heard of: jet grouting, compaction grouting, compensation grouting, vibro work with vibro-compaction and stone columns, micro piles and anchors. Obviously all these don't have a part to play in Peterborough, but somewhere they might in greater Canterbury. I'm with Keller. We're in joint venture with Brian Perry here in New Zealand. We're trading as re-level to use compaction grouting to lift and level, but this is about seismic mitigation, so that's where we'll keep it. The methods, I won't go through all of these, but just to make the point that there are many, many methods in the industry that address the soft side or the cohesive soils as apart from the granular soils. Your soil profiles here, which have been highlighted this morning and discussed, it's a bit of granular and it's a bit of cohesive. So from a ground mechanism standpoint as to what we try to do, we're looking to densify the sands, the cleaner granular soils, as well as to reinforce the siltier range of sands and the silts. So for us, it's somewhere between densification and reinforcement to mitigate seismic liquefaction, pick up your bearing, reduce either static or seismic settlements. We'll get down here quickly to talk just a bit about soil and mass mixing, some stone columns, speak briefly to wick drainage. We use both wicks and earthquake drains for drainage enhancement as we do the vibro work. Over excavation is your cheapest way to go. If you can get a meter and a half of poor soils out without being affected by your water table, you put compacted fill back in, reinforce your mat, maybe put some contingency in to lift and level after the next earthquake, and that might handle a lot of your problems at Peterborough. Cheapest way to go. Over X, put in a good raft, maybe with some contingency to relift. The loose soils were after densification, vibration. I won't speak to micropiles. I did put that in there, but piling's been discussed. Piling could be the answer to a lot of Peterborough as long as two things are taken care of, and those have been highlighted this morning. Your down drag under the earthquake and also the lateral support to the pile, meaning that you got to have something there after the earthquake, which a couple of the gentlemen have spoken to. Deep blasting, I don't think anybody wants to do that too much, and some of these other names. For the new sites, we'll quickly go through the vibrators. A bit of weight dropping. I don't think the CBD wants big weights dropping, but I did want to show just a couple of slides on what might be used in Canterbury. Soil mixing, and I won't speak to piling, which has been covered a bit, and other folks here are available to speak more to piling. The downhole vibrator offers densification reinforcement. Keller uses electric motors, which spins a bob weight down here in the nose, and you get a steady state pulsation in the ground, about 3/4 about 20 mil of amplitude, which is a steady state vibration. As the vibrator penetrates, it takes the clean sands down with it and densifies them, makes them more compact. Where the soils don't densify, we're putting stone in the ground for a better shear strength element. We use water conventionally, but we also have a dry system that's hooked up to an air compressor where we take water flushing out of the system and use air flushing. The system goes back to the 30s. In Germany, the first vibrators were designed and built to densify sands. You go into loose sands and you open up a hole. And you fill in the open hole with either a stockpile or you blade the site down. This is called Vibro-compaction. It's for clean sands. That's not what you've got here. You've got interbedded sands with silts. So we're after putting stone in the ground. We deal with diameters that are on the order of 600 to 1200 mil, and we're after three mechanisms. We're after densifying any clean sands. We're after reinforcing the silty sands and the silts with a better shear strength element, and we're looking for drainage. Okay? Densification, reinforcement, and drainage. This is work just completed at St. Andrews. Tonkin and Taylor it's Tony's work with Tonkin and Taylor. Stone columns were put in with a dry bottom feed system. This is not with water. This is with air compressor work to come up with a meter diameter. And then it's carved down a bit with geogrids and shingle placed on top for the concrete raft. Another tool that's available, we're using this in Auckland at the moment, it's called a Vibro-cat. It's simply a purpose-built track machine with the same vibrator working, allowing us to take a bucket of stone up to the top and the stone feeds out at the bottom. So the vibrator works up and down as the stone's being placed to compact the column and to drive it out into the soil to create larger diameters. Simon Woodward asked me a bit of drainage this morning. We use wick drains and earthquake drains to enhance our stone column work in the States. We don't look at drainage only. Other folks here might have other thoughts, but the instantaneous nature of the ground in these earthquakes trying to give up water, I would not agree with drainage only. What you're seeing here is we placed wick drains first. The vibrator is working second to install the stone columns, and we're driving water out. Taking water out of the soil is a form of ground improvement. And what we're doing here is to enhance the densification of the siltier range of sands by getting water out of them as we're placing the stone. I'll be brief here. We're not going to do this in Peterborough, but weight dropping might work with 5 tons. We use up to 30 tons in the States a lot. There is a bit of method to the madness. You've got to keep a crane together and you got to know how many times to drop something. The point I want to make here is that there's a dynamic replacement method available that if you place stone or busted up recycled concrete across your site, if you don't have off-site vibration problems, meaning you don't make your neighbors angry, you can drive the stone to 4, 5, 6 meters down in some soil conditions. Work has to be done significantly above the water table, meaning you don't want to drop into a swimming pool, but if you can manage the water table, stay above it, and drive stone into poor soils, you can replace them to depths 3, 4, 5 meters. When I first got here, I thought this would be great for new subdivisions and all of the recycled concrete available. This is work in Newcastle, a large Koelling loading facility. You see a couple different size weights that are simply driving the stone into the soil to displace the soil. The craters are created. We dump more stone in and continue the process to get displacement in soft soils. It's a replacement mechanism. Soil mixing is done with specially built paddle augers. We put in either a wet slurry or a dry bulk cement in order to create columns or secant-placed elements. It's pricier than some of the other methods. I point it out here because for lateral spread, it might be a player in Canterbury, possibly not Peterborough. Mass mixing is a dry bulk placement through an arm such as this on an excavator in which it goes out to claw the soft soil and to inject a bulk dry cement. The question this morning about peats, and I said we would address it with dry cement. A lot of dry and wet mixing as well as jet grouting has been done in southern Louisiana since Katrina and the issues with the hurricanes in which reinforcement or retrofitting of levees has been necessary. What you see here is about a 600-800 mil diameter paddle, same as the wet mixing tool, but we're putting dry to it. And we treat a lot of peats and organic silts with soil mixing, particularly dry. There is a subtlety to it that the cement needs to hydrate. So necessary here is a baseline study with the peat to make sure the cement hydrates and you get your design strengths. Most of the work I've been involved with, no issue. One recently before I left the States, got nothing for strength. The peat composition did not allow the cement to hydrate. Last slide, general cost magnitude. I'd be happy to comment to any of you on your specifics. I'm not going to put units out here. I've said before that if you can take out a bit of soil and knock back in structural fill, that's what you want to do. Then you drop weights, then the use of vibrators, the compaction grouting, which does have an element to play in existing structures with respect to picking up skin and tip resistance that's been compromised. We can drill down and pack the soil with the low mobility grout to improve the soil around piles and below them for existing. Soil mixing, chemical grouting I didn't speak to, nor soil frac, and jet grouting's a bit more expensive yet. But that's the way the costs lie, and I appreciate your time.
Any questions, Mark?
Yes, sir.
Compaction, you said that when you first arrived, you thought that would be a good one, but you've changed your mind.
My point is that when I first arrived, I had other thoughts than what I have today. It all has to do with insurance money and what new developers want to spend. I mean, the methods will play out with respect to how much money is to be spent on a retrofit or a new structure, and that limits it. My point here is that there are methods available in the industry being used every day somewhere in the world that can address your soil conditions. The money may not play. And yes, my thoughts have changed as to what I might be able to get done here.
But the dynamic compaction, the water tables are too high in general.
In order to get good weight dropping work done, you want to be at least 2 or 3 meters above the water table. So with respect to a new subdivision here, if this was a player and the water table was 1 meter down, you would probably want to put another meter of fill in over the site so that we're working at least 2 or 3 meters above the water table to get a big weight working like I showed you here. The weights I showed you were 20 to 30 tons on that Newcastle work. Big stuff. I mean, you can drop 5 or 10 tons, but to drive stone and replace soils, you need to be 20 tons plus, and you need to be a few meters above the water table. Yeah.
It makes a lot of vibration trouble to work, so you just wouldn't get away with it in Christchurch.
Yeah. Yeah, I put that in there just to let you see what was available. We're not going to do that, Peterborough. Yes, sir.
The stone column idea, how effective is that when you've got layers of peat that
It becomes a design issue as to what strength you get from the confining soils. Meaning you put stone into peanut butter, the stone could move sideways into peats and poor soils. So if you can't reinforce that very soft soil without keeping the stone somewhere where you want it to, then you go to other methods to get more rigidity with cement. So we try to get to that fine line where the stone is giving you value in soft soil and where you've got not enough confining stress laterally to keep the stone where it needs to be. So yeah,
Deep soil mixing's been done a bit in Auckland. It's very good for stopping lateral spreading. Is there any kit in New Zealand that's able to do that at the moment? Like,
any kit,
yeah,
the mass mixing or the individual columns?
either.
Yes, mass mixing and column soil mixings available in New Zealand, either by some of my other friends or from our kit out of Sydney. What I showed you here is ready to go. If we don't have, I mean, we have vibrators here, compaction grout equipment we've been doing work with for several 6 to 9 months with lifting and leveling and a bit of seismic mitigation. Some of the jet grouting and soil mixing we would kit from Sydney. But yes, New Zealand has some of this kit ready to go.